All right, so let's say you're given this diagram here of a four-particle system, and the question says, if I apply an external force F on the system above, what will the resulting acceleration of the system be due to this force? To start looking at the system above, we can know that this force is being applied to all particles. So we know for a system of I particles, this equation is true, where RCM is the vector pointing towards the position of the center of mass, Ri is the position of each particle, Mi is the mass, and then I is the number of particles in the system. And so, for example, if we have a system of 3 particles, I is going to be equal to 3, and the position of the center of mass can be written as the summation here. Additionally, we could transform this center of mass equation into an equation with respect to velocity by first multiplying both sides by the summation of mass, and then taking the derivative with respect to time of both sides, noting that the masses can be pulled out of the derivative because the mass of the objects don't change with time. We know that velocity is equal to change in position over change in time. So V is going to be equal to dr over dt. So we can substitute the velocities for these expressions in the equation and we get this. And then we can note that the summation of mass I, that's just going to be the sum of all the masses in the system. So we can change the notation to just represent it as capital M. So we get this expression here. This states that the velocity of the center of mass, VCM, times the total mass of the system is equal to the sum of all the individual masses times their individual velocities. So we can extend this to acceleration. So we know that acceleration is equal to change in velocity over change in time. So if we apply the same steps, we can substitute the acceleration for the change in velocity over change in time, and we get this expression here. So this just means that the acceleration of the systems can be represented by the acceleration of the center of mass. So we know in general that the summation of force is equal to mass times acceleration. This is Newton's second law. Extend this directly to the center of mass of a system. It's going to be equal to this, where the summation of F is the net external force on the collection of particles in the system. ACM is the acceleration of the center of mass of the system, and then M is the total mass of the system. And so this equation states that an object or a collection of particles, when acted upon by external forces, the center of mass will move as though all the mass were concentrated at that point and were acted upon by a net external force equal to the sum of the external force in the system. For example, if we take our system here, where we have this as the net external force, when we act this force on the system, it will move as though it was an object positioned at the center of mass. So the result is this here. So the force acts on it as if it were just this point here, where this point's mass is equal to the sum of the masses in the system.